Good afternoon, everyone. My name's Ross Livingston. I work for Clarke Fire. The presentation will be in Scottish today. The slides are in English. I'm going to try and slow my voice down. If I see people looking confused, I'll try and back it off again. But first of all, thank you for attending. The presentation is called Evolving Fuel and Engine Technologies for Sprinkler Fire Pump Drivers. We're going to kind of touch on different things, and hopefully there's stuff of value for everyone that's chose to attend. So in terms of a brief content, we're going to start with why diesel for sprinkler fire pump drivers. We're then going to look at air pollution in a USA context. We're going to look at engine emission technology. We're going to look at Clarke specifically and the fire pump engine technology that we are applying. Diesel fuel evolution, because we are seeing a lot of changes in the fuel side of our application and global applications. And then a final section on kind of reviewing energy solutions of the future. So the first thing I'll acknowledge is the elephant in the room. Some of this presentation touches on, sustainability and what's going to happen going forward. And quite a lot of the time people say, well, you're a diesel engine guy. That's fairly ironic that you're wanting to talk about the environment. But I'm hoping that by the end of the presentation, some of you might have changed perspectives. We've got some relative data that hopefully hits home. Obviously, the likes of Volkswagen haven't helped us. They've obviously made some bad decisions, and there's repercussions for them. So yeah, let's get into it. I wanted to include these pictures because we're obviously all here for the Sprinkler Conference. Our main focus is putting sprinklers in buildings and making the reliability as high as they can possibly be. So while the environment and sustainability is important, our first and priority is ensuring our fire pumps or the fire pump drivers work, and that the buildings and the people we protect, have the best chance of surviving these events. The images also highlight that, should a fire, propagate and get to these levels, the amount of emissions and air emissions that a fire of these levels cause is almost unquantifiable. You could almost lightly supply thousands of diesel fire pumps and run them for a decade, and it still might not add up to the emissions of a bad fire event. The one on the left was in the USA in Illinois. The one on the right was in the UK in London. So why are diesel engines the preferred power source for sprinkler fire pump drivers? The first one is, unlike electric motor-driven fire pumps, the diesel does not depend on an external energy source. So if you have obviously your diesel fuel on hand, you have access to air and a well-maintained system, that's going to start, it's going to run for as long as you have water or as long as you have diesel. With an electric motor-driven set, you're obviously relying on the supply from the power station, which may well be 20 miles away. When the fire department arrive, they could kill the power to the building. You might have an emergency genset. Hopefully it's been sized correctly for both the building's lighting and starting the fire pump, but we know from travelling the world that often isn't the case. So from an insurance perspective, diesel fire pumps are still considered the lowest risk solution for a fire pump system, and we believe that will continue. As I said, high reliability, very fast to respond. So our engines are designed to come online within 20 seconds and be supporting the fire pump at any flow condition. And finally, diesel fuel itself has a high flash point, which means in storage it's a relatively low risk fuel compared to gasoline and other fuels. So briefly going to touch on air pollution. So if we look specifically at a diesel engine, these are the main four categories of air pollution that is monitored, recorded and published. So you've got nitrogen oxides, hydrocarbons, particulate matter and carbon monoxide. In the US, I managed to source some data from the EPA. So this has looked at how various kind of air pollutants have evolved over a kind of 40-year time period. So the first column there looks from between 1980 and 2023, how did those air pollutants, evolve in the USA across various states. And the good news is, there's more or less, tremendous reductions in every one of those types of air pollution. Obviously, as the chart moves to the right, the time period's getting shorter, and the improvements are maybe less in the kind of last 10 years since those really big gains in the 80s and the 90s. Now I'm going to touch on the emissions technology of certainly the engines that Clarke supply today. So we have a kind of 4-level range. So starting at the bottom, we have what we call the Tier 0 engines. These really go from 45 horsepower to 875 horsepower. We call them Tier 0 because they technically have no emissions classification. When we supply these engines, both Clarke and our engine vendors do not commit to any specific level of emissions control. And these are certainly not used in North America. These are for kind of export markets in Europe, South America, Middle East, Southeast Asia. There's then the category called Tier 1 NSPS compliant. That's really a kind of older term that's not really, acknowledged or utilised in the market today. But Clarke does still have a kind of legacy range of engines, and they're rated from 41 to 275 horsepower. When we then talk about North America, Canada and USA, we have kind of two different categories. So we've got the Tier 2 certified engines, which are also classed as Euro 2 for anyone from Europe here, and they're from 755 to 1200 horsepower. We then go up a level to the Tier 3 certification level, or Euro Stage 3A, and that's in the lower power band of 86 to 700 horsepower. So it's really that the Tier 2 and Tier 3, we would classify these as emissions certified or emissions controlled engines, and they are an absolute must for North America and global markets that also respect that, such as Singapore. For anyone that's maybe not seen or understands the engine technology related to those emission levels, this is an example of a Tier 1 engine. A Clarke Tier 1 engine uses a base John Deere engine. So it's kind of older technology. Some might say rudimental in some ways, but it's good for fire protection because it's very reliable. It's a very kind of simplistic design. So these engines have what we call mechanical fuel pumps, meaning they're basically geared straight to the crankshaft of the engine, and they rotate in time with that. You can either have a rotary or inline fuel pump, basic spring-loaded fuel injectors. There's engine sensors on the engine, but it's very basic technology, mainly to satisfy NFPA 20 for alarms and signals. There's a governor in the engine, which is what controls the speed fluctuation between different pump loads. And again, the main point in red, these are not suitable for North America. As I said, they don't meet the emissions requirements for certainly this region. If we look at more the higher end emissions, the Tier 3 certified engines, these use electronic fuel pumps, so similar to what's on your vehicles, similar to what's on, continuous duty gen sets, very high pressure fuel injection compared to the mechanical engines. They have what's known as electronic control modules, sometimes called ECUs on cars, and that's basically the computer that controls the engine, every aspect of its parameters. The fuel injectors can be controlled electronically, meaning there can be very, very kind of small adjustments made in a millisecond or so. The engine sensors provide continuous live data, and the engine responds to that for emissions control. You'll see the picture there on the right. There's a lot of cabling on the engine. As I say, the technology is significantly more than those mechanical engines. This table here now compares those two different engine platforms. So from that kind of Tier 1 NSPS engine, comparing it directly to an equivalent power Tier 3 engine. These both use a John Deere base engine. And you'll see there on the right-hand side, there's quite significant reductions in the unburnt hydrocarbons and the particulate matter. The carbon monoxide's kind of negligible change. That mainly comes down to because at Tier 3 level, for fire protection, we don't want to go above that, because when you go above Tier 3 to technology that's maybe used in on-road, you're starting to use things like diesel particulate filters, selective catalytic regeneration, and some of that technology can actually reduce the reliability of the engine, which is obviously something we don't want for fire pump. When the engine's called upon, we want to ensure it's going to start. This table here shows a kind of short timeline. So within Clarke ourselves, we've done a lot of investment on emissions-controlled engines in the past kind of 6 years. So back in 2018, we had 64 kind of emissions-controlled engines that we supplied to our customers. For the constant speed engines, those that run at one single speed, they were limited up to 617 horsepower. And then on the variable speed kind of pressure control engines, they were limited to 526 horsepower. When we roll on 6 years to 2024, we now have 125 emissions-controlled engines. So we've kind of doubled our range for that kind of category of product. And on both constant speed and variable speed, we can now cover up to 1200 horsepower, which is normally maybe 95% of sprinkler fire pump applications. They're primarily for the North American market, but we do also export those to even non-emissionized countries, be that Europe, Middle East, Southeast Asia, because again, some people either want those brand of engines we're selling, or they maybe want to be more environmentally conscious and go with what is a greener option. Even now in 2025, Clarke is still currently developing more electronic engines for emission-controlled applications, and we're hoping that we can release even more product for our customers that will give them more options in terms of pump combinations to achieve more pressure and flow solutions for their customers. So a common question we often get is, okay, you have a range of emission-controlled engines, why is everyone in the world not using these? Why is it limited to North America and Singapore? There's various reasons, so we'll touch on some of those. The biggest one is national legislation doesn't require it. So sadly, like anything in life, it takes regulation to normally change human and commercial behaviour. No one wants to spend more money normally unless they have to do it and they're getting a truly perceived benefit for doing it. So as I mentioned, the Tier 3 kind of requirement, it's only really US, Canada and Singapore that is a national regulation. There's some maybe specific states, obviously in Germany, that market is kind of split up a bit more, and we do see unique requirements in specific regions of countries, but in terms of a pan-country regulation, it's only US, Canada and Singapore just now, but there is no doubts that others will follow. We're only going to see more regulation, more scrutiny on air emissions. The next big one, monetary decision. So with that advanced technology on those electronic emission-controlled engines, they are naturally more expensive than the basic mechanical engines. You could easily be looking at a kind of a 40% price difference for an equivalent kind of power and speed rating. So it's no small amount of money, and for an area that doesn't maybe require emissions control, our again main focus is getting sprinklers in buildings, getting fire pumps in buildings. So we don't want that to become cost prohibitive, that it prevents a sprinkler system being installed in a building. That is our main priority. There's also limited supplier options, so it does take a lot of investment and it does take the right kind of partners to develop these type of engines. Currently the market has select companies that can supply them. Again, we don't doubt that will change moving forward as kind of global regulations change and more countries mandate this. Also, in terms of the actual pump operating speed, the kind of industrial engines used for these emissions controlled applications, they're normally only up to kind of 2350 RPM. So the actual fire pump speeds are kind of limited as to what they can be applied at. A lot of the world, certainly Europe and Southeast Asia, even the Middle East, a lot of them work off of 50 hertz, which is 3000 RPM for electric motors and diesel engines. So again, that's another reason why sometimes the Tier 3 emission control product might limit the actual combination or solution the pump company can do. And then the last one is knowledge gap. So when we've been given some of these presentations in recent years, we've had feedback from even people quite high up in different organisations that say, we didn't know these products were available. So again, that comes down to ourselves, our competition, to better educate the market, let them know what solutions are available so they can then educate downstream and decide if this is a good solution for them or not. The next couple of charts is just to kind of give some relativity. So I basically compared those Tier 1 kind of basic emission controlled engines that are, again, from a previous time, no longer a kind of a respected emission standard, and then compared that to an on-highway truck. I believe you would call them a semi-truck here. We would call that a Euro 6 engine in Europe, and I think 2010 is when the last US kind of legislation went into effect. I know recently the current administration have, I think, changed some legislation that was going to come into effect for California. It's obviously quite a topical conversation. But the whole point of this chart is trying to show, for a diesel fire pump application, it's only expected to run 27 hours per year. It's one of, if not the lowest hours of operation diesel engine applications in the world. So yes, there is emissions from the product, but it's all relative when you compare it to a highway truck that on the far side, say, drives 56 hours a week, every week of the year. If you actually total up the emissions it's going to generate, the fire pump, engine, it's minuscule in the grand scheme of things. This puts that into a kind of graph format, which is faster to obviously, appreciate. So, the first kind of darker blue is the diesel fire pump engine, the older Tier 1 NSPS engine. The middle kind of turquoise or lighter blue is a truck driving 25 hours a week, and then the red is a truck doing 56 hours a week. I will let you kind of, have the takeaway, given there's millions of trucks on the highways today. Same thing again, but this is now comparing that Tier 3, those higher emission controlled fire pump engines we have in the US, Canada and Singapore, and again, comparing it to the semi-truck driving 25 and 56 hours a week. And again, it's a more exaggerated situation again. So again, we just show this to put it in relativity. Yes, a diesel fire pump has emissions, but there are many more applications that have a much more profound impact on overall air emissions in obviously a country, but also globally. The next section is more looking at the technology Clarke as a company have developed in recent times to try and enhance our product, the experience for customers, and hopefully the experience for the end user ultimately. A big investment we've been doing over the past 4 years is in our engine instrument panel. So in every kind of ULFM, NFPA 20 sprinkler fire pump engine, we have our own engine mounted control panel. This monitors various parameters on the engine. It decides when to send alarms to the fire pump controller. The fire pump controller, speaks back to our engine control panel and ultimately decides what the engine should do. We've developed what we call the TSPM and TSPE, so touchscreen panel mechanical and touchscreen panel electronic platforms. And as of 2025, these have now been rolled out across our entire engine range for all mechanical engines, all electronic engines that we are supplying. So it's switched over from previous platforms. It now has a full touchscreen capability. It's got detailed event logging. So just now, fire pump controllers have to log events. So you can understand what a user or the pump has done in terms of operation. But Clarke decided to go a step further, and we have now added event logging into our own engine panel. There's various reasons to do that, but a key one was getting that additional information. Also, if someone switches off the fire pump controller, which people choose to do every now and then, there's no information. So we can't learn from an event, we can't learn what has happened. So, by building in that technology, we can understand events more, we can hopefully improve the product, we can share information with insurance companies and various other kind of stakeholders. The circuitry also has thermal circuit breakers, so on previous platforms, if there was an installation error and someone reversed the batteries, you could very easily damage the electronics. Now that we have thermal circuit breakers, the componentry is very well protected against user error, which will always exist. The enclosure of the panel is NEMA 4 standard or IP66, and the wiring connections have also switched to what we call cam lock connectors, which is basically like a push lock mechanism, whereas before it was tiny screws, and again the feedback always wasn't great for them in terms of the installation experience or issues that might arise from them. Now, these panels are on display at our booth. We have them on the mechanical engines and the electronic engines. We would encourage you to come across and have a play with them, get that user experience and ask any questions you might have. Another thing that Clarke's invested in is the cooling systems for our engines. So, in previous engine generations, we would use, components from other suppliers for the cooling system, but we kind of decided, like our charge air coolers and other parts of the engine, we wanted to improve that for the fire pump application. So we have now developed our own heat exchangers. There's various benefits that come from these. The product is called the NSR, which is nylon-supported rubber. It is the kind of platform design. They have removable end caps. They have replaceable seals, cleanable tube stacks. So the kind of central part of the heat exchanger can now be serviced, whereas some of the previous brazed copper versions were kind of a sealed unit, so to speak. So again, we believe this gives everyone downstream the benefit of the product being serviceable. Certainly for the end user and the service companies, we think these products will be really well received. And we've also developed specialist materials. So The standard design is for freshwater, but we've also developed 9010 copper nickel for aggressive seawater environments. So the product's designed for those vertical turbines and various fire pump applications that we're dealing with. Another aspect of technology that we've spent time and money on is data verification. So if we go back 10 years ago, kind of counterfeiting wasn't really an issue, but over the past 10 years it has become an issue in various parts of the world. People trying to imitate the product, trying to falsify the ratings of engines. Various things happen. So we basically took technology as a way of kind of defending against that, and on every Clarke engine now we have this kind of design of nameplate you'll see there. The nameplate has all the normal ratings for the engine in terms of its fire pump application, but everyone now has a QR code in the bottom right hand corner, and anyone using their phone can take a picture of that. It links to the Clarke website, it shows you the rating of the engine, it shows you who we sold it to, and it also links to the operation manual, installation manual, and various other things. So we think that's a benefit for our immediate customers, but also when it gets to the end user, the person that needs assistance urgently, we're trying to give them the access to the website, trying to get away from the physical manual, the 50 pages of text, and try and get people the support they need fast. And there's additional things we're working on that we're hoping to roll out in the coming years. We also offer advanced engine data performance monitoring. So within NFPA 20 and UL and FM, there's obviously certain parameters we have to satisfy. But again, over the years of Clarke doing the business we do, we've learned of customer requirements for even more data, more information, and we've developed an additional kind of module that goes on the engine. This can, preemptively advise customers the engine needs service. They can bring that to their attention. There's obviously a lot of talk going on just now about remote monitoring, remote testing. So, this is industry developments that Clarke are trying to stay up to time with. We're trying to, play our part in applying modern technology to what is a kind of, older-fashioned product. So yeah, these are various aspects of what Clarke is trying to do to benefit our customers, benefit the end user, and again, hopefully try and move the industry forward ahead of even what we are required to do so. The next section touches on diesel fuel itself. Now this can quite often be a controversial topic depending on where you are in the world. And depending on where you are in the world, there's often different challenges when we talk about fuel. So some might be relative to here, some might be less relative, but hopefully you get something from it. So the longest standing diesel fuel is petroleum-based diesel fuel. So this is fuel that's obviously made from crude oil, fractional distillation. The most common global standards for that is ASTM D975, 11B, more commonly known as number 2 diesel. That's what is most prevalent in the USA certainly. In Europe we have EN 590 2009, and then in the UK BS 2869 2017. So the pros are the benefits of petroleum-based diesel. It's widely used. It's got a very consistent supply globally. Most engines are designed for these specs. So most engine companies or OEMs, that's what they're using when they're doing their R&D and developing the engines they currently have. Finally, it's relatively stable in storage. So in terms of how the fuel breaks down, normally petroleum-based diesel is pretty reasonable. In terms of cons, if we're looking at this from a sustainability perspective, petroleum-based diesel is considered to have the largest carbon footprint or the largest well-to-pump life cycle analysis. So obviously there's energy involved in extracting crude oil, energy involved in refining it, and then obviously energy to then distribute it to its various outlets. There's then a fuel called FAME biodiesel, fatty acid methyl ester. This isn't so great. Many people in the room will know about this already and will know why it's not so great, but it is important to touch on it. So this is diesel fuel, which has basically been created from a process called trans-esterification, and that's not easy for a Scottish person to say. And it's basically taking vegetable oil and animal fats and trying to reprocess them into a fuel product. Again, in terms of specification, in Europe, we have EN 16709 and EN 14214. Here in the USA, you have ASTM D6751. In terms of pros, It does have a reduced engine operational emissions. So if an engine is kind of ran back to back on petroleum diesel and then ran on biodiesel, they normally will see a reduction in particulate matter, carbon monoxide, and then unburnt hydrocarbons. It has a lower carbon footprint, so again, you're taking a waste product, you're not extracting anything from the ground or under the sea, and you're refining it. It has a higher lubricity, so because it is made from fats and such like, it inherently is a kind of a greasy product. But in the cons, I'll come back to that. So it's the big downside, and I've put these in red, so hopefully they hit home. It's very unstable in storage, so within 30 days, biodiesel's breaking down. You get a thing called microbiogrowth, or diesel bug is another name, and these pictures on the right-hand side try to show that. So the fuel kind of gels up. There is a kind of bug that basically festers in the fuel and kind of populates. In terms of engine power, the engine could be down 12% on power compared to a petroleum fuel. And in terms of maintenance requirements, because of how that gels up, how it might block fuel injectors, block filters, block fuel lines, it increases maintenance requirements. So again, for a standby diesel sprinkler pump that isn't getting ran often, the fuel is stagnant, the fuel tank maybe isn't getting topped up regularly, biodiesel is a big no-no. It is the worst thing you could do for our application. The biggest challenge is that globally, governments are mandating the blending of biodiesel. So, historically you could get 100% petroleum diesel, or you could get, 100% biodiesel. But most governments are now more or less forcing countries to blend percentages of both together. So quite often it will at least be 5 or 7%, even in what you would consider petroleum diesel. But there is countries like Indonesia which mandates 30% biodiesel. So, and that is everywhere in the country. You cannot get pure petroleum diesel. So it's a big concern for the application. The final type of fuel, and quite often this can be confused with biodiesel, is what is known as renewable or green diesel. It's sometimes called RD100 or HV100. And this is known as hydrotreated vegetable oil. So in terms of how it's been distributed in the market, it's a relatively new product. It was kind of designed and made 20 years ago. It's made from a process called hydrotreating or hydrocracking. In terms of the EU, the specification is EN 15940. Again, it's got reduced engine operational emissions for particulate matters, carbon monoxide. It's got a lower carbon footprint, higher cetane number, and it's very stable in storage. The downsides is, again, it might reduce engine power by 5%. It can cause seal failure on engines that have previously ran with a level of biodiesel in them. So when this new fuel, renewable diesel, goes in, it can kind of affect the rubbers in the system. So it could basically take the engine down. It could block the fuel pump and make the engine fail, which is a concern. And it also has a reduced energy density by volume. So you need to consume more fuel to make the same amount of power. I'm not going to talk about the emissions improvements because that's not my job, but there is a table there from an SEA study that shows the reduction that fuel might have on a back-to-back test. In terms of the engine OEMs we work with, all of these companies permit that fuel. They do have their own kind of stipulations in terms of power loss and additional fuel consumption. To be clear, Clarke's position is that we are currently only recommending petroleum diesel. So there's still a lot of learning to do on renewable diesel, HVO, in terms of that loss of power, the increased fuel consumption. There is concerns that the fire pump might not be able to perform at that, end of curve point in terms of maximum flow, maximum pressure. So there's additional understanding and research needed on our part, as well as other stakeholders. So, as I said, that is our current party line. It's something that might change in time, but as of today, that's our position. Finally, looking at future energy solutions, the world is changing. We see that for smaller scale and local operations, whether it's charging infrastructure, low load demands, and low to medium operational hours, battery and hydrogen fuel cells will play a role in our environment. Where we think there's still going to be a combustion fuel preference is where you have a large scale or remote operation application, where there is no charging infrastructure, high load demands, medium to high operational hours, or it's a critical application. And obviously, a fire pump would fall into that category. So the final slide we want to finish on is the right solution for the right application. So obviously we are diesel engine guys, but we do believe the energy challenges of the future will not be solved with one solution. Batteries will not solve all of humans' requirements for transportation and the way we live just now. And in reality, our built environment will need various solutions. We believe the fastest route to this carbon neutrality journey is obviously adopting, technologies that's available today that can reduce the emissions of existing infrastructure, be that on road vehicles, be that on diesel fire pump drivers. So, it's a journey. There's going to be lots of changes. Clarke's trying to stay close to that, and we're trying to benefit, everyone in the supply chain to give them access to these benefits as well. So I thank you for your time. You'll obviously get a copy of this where you can, review it. I hope you understood some of my Scottish today, and thank you for coming.